Okay, we're now going to talk about the Wave editor and how it works, and in particular how to extend it with its extension mechanisms. And we're joined over VC by our glowing sphere of genius, Dan Danilatos, who wrote the editor. So any difficult questions, I'm just going to field off to him. So just to give some context, by Wave editor, we mean the rich text editor that runs in the browser, and it sits on top of the operational transform layer that Wave provides. So it's about editing content, using operations to describe the content, applying operations that come in, and all these operations are then just handled by Wave and the network. So in order to understand why the editor is structured the way it is, it's important to understand the goals that were set out when writing the editor. And this is probably the most concise description that we can have, which is it's a toolkit for rich, extensible, real-time, collaborative editing. So rich as in rich text. It's extensible in that you can add loads of programmatic extensions to it. It's real-time, so it's fast, it's live, and it's collaborative, which means it operates on a distributed document model. You make local mutations, they get sent out. Incoming operations from a server can come in and apply. So it enables having a rich document model that is kept semantically clean. The rendering is a completely separate concern. The document model is separate, which means it can be designed using a structure that performs well under transform. And by keeping the rendering separate, it means that we can use proper semantic HTML. We can use HTML the way it was meant to be used, with paragraphs, line breaks, list elements, all the proper semantic markup. The core parts of the editor help abstract away browser quirks as well. It gives a consistent API for adding in editing behavior. And there's an API for building extensions to the editor, and these extensions we call doodads. And the reason they're called doodads is because widgets and gadgets are both names that were already taken. So when we say the editor, it's not a completely clear definition of what that is, because it's an open, extensible system. But usually what we mean is the core framework of the editor and the Wave document model underneath it, as well as a bunch of sort of standard default features that are installed, like paragraphs, bullets, styling, maybe some other doodads like image thumbnails and maybe gadgets. But it's an open-ended set of features. So it's not, when we say the editor, it's not a clear-cut definition of everything that encompasses. But yeah, the design goal is that you can add in lots of extra features, and these features operate at the same level as most of the core features in the editor. So the first question that you need to address when you're building an editor in a browser is how much to use the browser's native support for editing, which is called content editable. And some web editors entirely let the browser do everything. For example, the closure editor that's used in Gmail, it's all based on content editable, so everything you type, the browser is doing all the editing and updating the DOM natively. Other web editors like Bespin, which is the Mozilla editor, everything's handled programmatically. So everything you type, it's JavaScript code that's executing and updating the DOM. So in Wave, the editor, it tries to strike a balance between the speed and convenience of letting the browser do its thing, but as well as the application flexibility of handling everything ourselves. So we try and leverage what the browser does well. So fast typing, selection support, moving the caret around, cut and paste, IMEs, these kinds of things, we let content editable do its thing. But For many other things, we handle them all programmatically. So the editor is designed so that you can strike a balance. You can do whatever you want to do manually, or you can let the browser do whatever you want by default. So it's kind of content editable on a very tight leash. So the bulk of this talk is now going to talk about rendering the document model. So even though this isn't really part of editing, it's a core part of interacting with the editor. So by rendering the document model, we mean in Wave, the document model is this clean semantic model, doesn't know anything about HTML. It's just a representation of the document, and it uses line elements to separate lines. There's text. It's all wrapped in a body element, and it's all a very simple structure. And we use the XML part of the document for structure, like text and lines, but for stylistic things, we don't use structural elements. Instead, we use annotations. And you might recall from other talks how annotations work. We'll see some more annotations later in this talk. So an example of this separation between the logical model and the rendering comes up when we try and extend the editor, for example, with an image thumbnail. So here is an example of an image thumbnail that we might want to embed in the editor content. And in choosing a logical representation for the data in this model, we're free to choose whatever representation we want. So in this case, we represent everything structurally. There's an image element with an attachment attribute that will identify some image. Within that image element, there's a caption element that contains some caption text, but we're not constrained to use something that will work with HTML. We can use whatever data model we want. And this simple, clean, logical model then renders to some disgusting HTML, because HTML is not at all designed for arbitrary layout and drawing. So instead of having the editor operate on HTML, which would mean logical content looking like something on the right, which is ugly, the logical content is kept clean, and there's a whole rendering system within the editor to render to arbitrary HTML. So this correspondence between the logical model and the rendering model is done by using references between two trees. So on the left, we have a picture of what the logical content might look like. In this case, just an image element that contains one child, which is a caption. The image element has an attribute on it. And on the right, it's corresponding HTML, which is that big, heavyweight tree of elements. And the correspondence between these two trees is kept with references from bidirectional references between various nodes in the tree. So in this case, the image element maps to some top-level div, and the caption element maps to where it appears in the rendering. So there's two main flows within the editor. Just like if you remember from the talk yesterday about the wave panel, there's two main control flows, which is two main data flows from when data goes from the model into the display, and from when events happen in the display, mapping them back to changes in the model. And these flows are called rendering and UI handling. If you look in the code, the rendering is all done through a type called node mutation handler. So anything that does rendering, they're all node mutation handlers, and handling display events are done by what are called node event handlers. So now we're going to talk about the rendering flow. So in that caption example, that was a fairly simple mapping, and by simple, it means that ancestral relationships are preserved. There was an image element that had a caption child, and the corresponding HTML, the rendering of the image was still an ancestor of the rendering of the caption. The editor permits more complicated mappings that don't need to preserve that kind of simple relationship. So one of the key examples is how we render lines. So in the logical document, a line is encoded as a line element followed by some text. But when we render that to HTML, we want to use proper HTML markup, so it's text wrapped as a paragraph element. So how on earth do we do these more complicated mappings? And in order to explain this in a bit more detail, I'm going to introduce the concept of local nodes. And local nodes are parts of the logical document that are not considered part of the persistent content. Local nodes will only show up on in the client that creates them. They're not transmitted to the server. It's just an extra overlay of extra information within the structure of the document. So they take up zero size. Incoming operations that touch the document just know how to apply around these local bits of state. If you're interested in the code that does it, there's a class called persistent content, and that contains all the details of how to resolve conflicts like server operations applying in places where local nodes currently are. But these local nodes of just some local overlaid state is a key mechanism that's used in the editor for doing rendering. So back to this example of how do we render lines. The trick is to apply some local nodes to the content to transform it into an intermediate representation which is more suitable for rendering. So in this case, any text that follows a line element, we take that entire chunk of text and wrap it in a local node. And you can identify local nodes because they all start with L:. And once these local nodes are in place, it's a much simpler mapping to map this to the rendered HTML. So this end-to-end mapping, sorry, that will come up in the next slide. So these local nodes, one of their main uses is for an intermediate representation to assist with rendering, but they can really be used for anything. Arbitrary features that you install in the editor can put in their own local nodes wherever they want for local bookkeeping specific to your feature. So how is this local overlay of state, how is this exposed? So the document model supports different views, and two of the main views it exposes are the persistent view, which exposes just the content that is persisted on the server, so just the content that is shared with everyone else. There's the full view, which extends this state with all the local nodes. There are some other views as well, but they're not important for this talk. But the key thing to take away is that the document model is a view-based model where all these different views are all overlaid on the same state. So this diagram shows you the control flow of what happens through this intermediate representation. So on the left, there's the persistent model, and when line elements show up in this persistent model, the corresponding event handler for the line elements gets notified of them. It wraps the blocks of text that follow the line elements, wraps them in these local paragraph nodes. When these local paragraph nodes show up, the renderer for those nodes observes them and figures out how to update the display with HTML that will look like paragraphs. So these renderers are kind of chained together through this data flow. Okay, the next thing I'm going to talk about is annotations and how annotations are rendered. So you might recall that annotations are not structural parts of the document. It's a separate data structure that sits alongside the document. And the abstraction is that for every item in the document, an item being a character or an element start, element end, for every item there's a map of key value pairs. So in this case we have two sort of ranges of annotations that overlap. So annotations can freely overlap, and this makes it not trivial to paint them because HTML doesn't have any first-class support for this kind of abstraction. So because annotations are usually used for sort of more decorative markup like style or just some extra metadata, it's not always essential that every client has to paint them, and it's usually quite fine for clients to ignore annotations that they don't know how to render, because most of the key content is in the structure. So in Google Wave and Wave in a Box, the kinds of things that we use annotations for, we use them for tracking cursor positions and selection as you see multiple people editing a document and you see their name next to some location. That's done using annotations. Links and spelling corrections, those are done through annotations. Diff highlighting, so they are used fairly extensively. So because HTML has no abstraction that corresponds in any way to these annotations that describe or that apply to items in the document, it's not immediately obvious how to render them. But the trick that we use is to use these local nodes again as an intermediate representation. So on this slide you can see an example logical model on the left, and I should point out it's a slightly old slide. You'll see P's in there, but we don't have P's in our logical model. Imagine that they are the line elements that should be. And you can see a bunch of annotations on them. So there's an annotation on the misspelling of have. On the this, there's a link annotation. And the desired rendering that we want, the way we want to show it up in HTML, is pictured on the right, where the misspelling has a red underline on it, and at the right-hand boundary of it, there's a drop-down arrow to correct it. So how do we get there? And the trick is there's a class called Annotation Painter, and what the Annotation Painter does is it identifies spreads and boundaries of regions of the document that share the same set of annotations. So, and those contiguous regions, it wraps them in spreads and puts in boundary nodes that indicate boundaries. So in this example, the text HAEV that was annotated as misspelling, the Annotation Painter has wrapped this with a local node to identify as a spread, and it's put a boundary node after it that identifies that there was a change in the annotation value there. So once all these decorating local nodes are in place, you can see that mapping these this representation of spreads and boundaries, mapping this to HTML that will give the rendering we want, this is much more straightforward now that we have this intermediate state. So along with local nodes, there's the equivalent concept for annotations. So local annotations, again, they're not persisted, they're sort of overlaid onto the document content. They behave just like regular annotations. You can annotate any part of the document. The key difference that makes local annotations special is that unlike persistent annotations, local annotations don't have to use just primitive values. So annotations are just key value pairs. Local annotations are free to use any type for the values, including object references, because they're not sent to the server, they're not persisted, it's just local in the client session. So this is very handy for a number of UI features that want to store state in the document. Okay, so that covers, very briefly, that covers the rendering path. Now it's just a couple of slides on the event handling path. This diagram here gives you an overview of the structure of the event handling flow in the editor. Going from bottom to top, there's the editor responds to native browser events, like typing, clicking, pasting, and there's a layer on top that normalizes these events and tries to abstract away browser quirks and the different event models that are on every browser. It also makes the events a bit more semantic in the context of editing. So it will interpret events like selection movement and enter being pressed, these kind of events. It makes them first class. And it also routes the events to the layer above. And above, there's a kind of first class distinction between things that do things programmatically versus the things that let the browser do its thing with content editable and then try and observe what it did and synthesize operations out of that. Those latter ones we call extractors. So there's a few extractors built in, but most things in the editor are done through handlers, and handlers operate at the same level as custom handlers that you add when you add your own doodads. And yeah, handlers observe events and mutate the document model above it. Yeah, question? They'll show up in the following slides, but the two main extractors are there's a text extractor and a paste extractor. Yeah, so it's rather than interpret a browser event entirely manually, we let the browser do something natively and then observe what it did to the DOM and then interpret an operation out of that.
So with this model, if I type in a character,
Mm-hmm.
the character appears on the screen immediately, and then you post-process and find out what the character wants.
Yeah, so that will show up. That exact example will show up in a couple of slides. So yeah, this is just a bit more detail on what those event layers are, but I've already talked about it. So this example. So I'm now going to go through, I think, about 5 quick examples of the flow of editing interaction in the editor. First one being the 99% case of just typing regular characters. And again, the goal is to make it fast. Even tiny bits of latency as you're typing is very easily noticed. So typing events, we let content editable usually do its thing. We schedule a timeout to run a little bit later to observe what the browser native editor does and extract operations out of that. So this means that typing is just as fast as it is in a native content editable region. But that's only for very basic typing. Yeah. More or less, yeah. So for something a bit more sophisticated, like pressing enter, where enter is kind of handled specially. There's custom logic that's registered in the paragraph doodad, and this handles the event completely manually by splitting a line by putting in a line element, and then the corresponding renderers kick in after that. So the reason this example is important is that the way enter behaves is different in paragraphs versus if you're in a bulleted list or a numbered list. And all this behavior is done in the Wave editor. It's all done completely programmatically. It's all under application control. And this just demonstrates the flexibility of you can either let the browser do its thing or you can have complete application control. So paste is an example of something that's a little special. In order to protect the logical content and to protect the rendering, we do need to let the browser do a paste somewhere, because otherwise we don't know what the paste is going to be. But we don't want it to go directly into the rendering because that might munge it up. So paste is handled by moving the selection to an off-screen element. The browser will paste some content in there, and then paste is handled through an extractor that then goes and looks at what the browser pasted in that off-screen element and interprets that as Wave XML and makes the corresponding logical insertions into the document. And I should mention that this trick also lets us do semantic paste, where if you select some content within a Wave document and then paste it somewhere else within a Wave document, it's not that the paste comes through as HTML and we kind of have to reverse engineer what was the Wave XML that went in there. There's a special path that lets us preserve exactly the semantic HTML that's used in that case. So it's just 2 more examples. One is a stylistic example. So when you hit Control B, what happens? Again, we don't let the native content editable editor handle this because the native editors do all sorts of crazy stuff to the DOM. Instead, there's a key handler that's registered in the editor that handles this, and it's handled by using a style annotation. So it annotates the logical content with the region that's been selected and puts an annotation on it, and then the Annotation Painter kicks in, puts in the spread nodes and the boundary nodes, and there are registered paint functions that paint this annotation using CSS style attributes. And the last example, I'm not going to explain anything about how it works other than for IME, keyboard input, this is too hard to do programmatically, so instead this is something that's let through to the editor, let through to the content editable native editor, and then we extract what happens afterwards. Okay, so we're going well for time. Any questions on the content? Yes? IME stands for input, something extension. Dan, what's the right?
Input method editor.
Input method editor. It's for like multilingual, like typing in Chinese or typing, yeah. Mm-hmm.
So, our editor, we went the route of actually not letting the editor handle anything. We actually did everything programmatically.
Mm-hmm.
But then one of the issues we had with it is just so slow to rebuild the doc anytime you use to type anything.
Mm-hmm.
How did you guys solve, like, what do you do when someone makes a change that comes across the network and it's just one character? You don't rebuild on top.
No, so everything is mutated incrementally in place. So in the case of a remote operation coming in to insert a character, that will get inserted in place in the logical content. You might remember in one of the earlier slides, the mapping between the logical content and the rendering. There are these bidirectional references between various nodes. So there's some sort of intelligent incremental stuff that just makes incremental mutations to the rendering. It's not completely rebuilt all the time. Yeah. Any other questions? Okay, great. Maybe just take a quick 1 or 2 minute break, because the next talk we're going to go through building a doodad, which is going to be fun. So I'll just get that set up. Yep. Okay, let's get back into it. I'll do a lightning run through extending wave content. So we're going to build a doodad and give you a flavor for the development process of building a doodad as well. So just one slide here. Most of this talk is going to be inside Eclipse and inside something that just got checked in yesterday or the day before, which is called the editor test harness. And so I'll give a quick tour of the editor test harness, what it is, how to use it, and then if there's time, I might just briefly describe some examples of existing doodads that are used within Wave. Then we're going to build an example doodad, and the doodad we're going to build comes from, there's a tutorial that's now online, I think, that's quite in-depth and quite detailed, covers all parts of how to write a doodad and how to add custom behavior and custom renderings within the editor. Okay, so the editor test harness, you can run it in a number of ways. So if you have a recent update of the Mercurial repository, I think this is the libraries repository. There's a package in there, client editor.harness, and within there's a launch configuration you can run. When you run it, it'll start up GWT's hosted mode server, and then you launch that and you'll get an application that looks like this. And what is on screen here? Unfortunately, it doesn't fit too well on a narrow screen, but here there are two editors on this page. There's an editor here on the left. You can see me typing here. So on the left, there's an editor. Operations that are coming out of that editor are then getting applied to a second editor over on the right, just so you can kind of, it gives you a mock environment of two concurrent editors happening. You can edit in either one. Operations get propagated back and forth between the two. Below the editor, you can see here the logical content that is in the editor. So here it's the document, the body element, the line elements, and the text within them. And you can see that these have been wrapped in some local nodes. You can see the local paragraph elements here. Then on the right, you can see the HTML to which that state has been rendered. So here it's all divs and ULs and line breaks and things. And this mapping is, you can see the correspondence between this rendering and the logical content now that it's been marked up with local nodes. Now, there's lots of buttons for doing fancy stuff. The main stuff that we're going to use is just typing in one editor. And there's also a field here where you can enter in the logical content that you want to show up in the editor, just to help bootstrap development. Okay, so the doodad we're going to build is an image doodad that looks very much like the image thumbnail doodad that's in Google Wave. And what's in it? So it's an inline image doodad. It's got an image and it's got a caption within it that you can type in. And so we don't have time to build the whole thing from scratch, but what I'm going to do instead is point out the finished content and like poke and prod around it a little bit. So there's two main classes here that will be of concern. One is what's called the entry point module. So I know most of you haven't done much work with GWT before, but the unit of modularization in GWT is called a module, and you build your application up out of these GWT modules, and you nominate one module to be the entry point for your application. So this code here is just saying, here is a module to be an entry point, and the minimal code that you need to get things running, if I click the right button this time, that one. The minimal code you need to get things running looks just like this. You create an editor harness object and you just run it, and that's it. And if you do that, you'll get the page that I just showed you before. But in this tutorial, we've put in a bunch of things to work with the doodad that we're writing. And the doodad we're going to write is called my doodad. And the key part of installing a doodad is typically a static register method on the doodad that accepts a registry into which it registers its various parts. So we're going to start off from the very... I might put this up here. So from the very base case, when there's nothing registered, what happens? So now I'll just refresh the harness. This is Eclipse. This is GWT's hosted mode code server running. It's recompiling the application. So if we put in the logical content a reference to my doodad, then what shows up is a default rendering. And the default rendering of doodad is just a grey box with the name of the doodad type in it. So if you see this, this means that the default renderer is kicking in, but what we want to do is register our own renderer. So the simplest case is here we have a simple renderer. What we do with it is to register that renderer for the tag name of our doodad, and the tag name in this case is my doodad. And what does that renderer look like? So this is that renderer. You can see it extends a mutation handler. That's not good. And the way it's going to render the logical content of the doodad is just to translate it to an HTML image element. And that's this code here. And it also responds to modifications of I should point out, the way we want to represent the state of our doodad. Start off with, it just has a reference attribute that points to where the image is. So in code, we just translate that to the source attribute of an HTML image element. So that's this simple renderer. So if we write that and register that, these doodads will start showing up like this. So it's just an HTML image. Wasn't that nice and easy? So the next thing we can do is attach some behavior to this doodad, and we're going to do that with a simple event handler. And we have to register that event handler. And the behavior we're going to add is this code here. All we have to do is to say that when the doodad gets activated, we register a JavaScript event handler so that when we click on it, it brings up a prompt that will let us change the reference attribute of it. So that's all this code here. It's pretty tight and compact. So now installing that handler, refresh, we'll see the next stage of the doodad. I have to remember another. Try this doodad. So we click on it, and the handler we registered has now been invoked. And the code in our handler takes the value that we put into this window prompt, updates the ref attribute in the logical content, and we'll see the renderer that we registered, the renderer kick in and update the rendering by changing the source attribute of the HTML image element. So that's all it takes to add custom rendering and event handling to elements in the editor. So the next thing we're going to do is use a more sophisticated rendering. So we need that. And yeah, I'll just and this more sophisticated rendering is going to use a GWT widget to do the rendering. And in the editor extension mechanism, if you want to put in GWT widgets rather than just native HTML, then there's a special mutation handler that takes care of a lot of the GWT hookup for you. So in this case, we're running a GWT renderer. And again, it has the same sort of structure. On modifications of the ref attribute, we translate them to modifications on the widget. So that GWT widget itself, is just in this example, it's just a stock standard way of writing a GWT widget. There's a corresponding UI binder template that just declaratively describes the HTML. I won't go into any detail about the implementation of that widget. So now we should see a more sophisticated rendering. So it's a bit fancier. It's got a beveled background for it. So it's using a GWT widget. Eclipse is going to die on me now. Here we go. So the next thing is to attach the behavior again. And to also think about starting to render that caption element. So within that, the logical content, there's a caption element within the image element, and how we're going to render that. Let's see. That should do the trick. So the key thing to understand about having doodads for composite structure is this concept of a doodad's container nodelet, which is this method here. So the usual case where you have a composite structure that you want to render, in this case there's an image element. Sorry, there's a my doodad element that has a caption within it. Usually you want the rendering of the child to be contained somewhere within the rendering of the parent. And for this 99% use case, there's a very simple way that you can specify how to hook up the two renderings. So you've got a rendering for your doodad, which renders to that GWT widget I showed you before. There'd be a separate rendering for the caption element. And there's some default behavior that looks when the editor is rendering these two parts, it tries to look for where to put the child within the rendering of its parent, and you can declare where you want it to go by overriding this container nodelet method. So now we should see the image with a rendering of a caption in it. And there we go. So this caption part has been rendered by a separate renderer, and the editor knows how to hook it up using that container nodelet mechanism. And there's only one next step I wanted to point out. Something is not right. I need that one. So by default, if you hook up a widget like this, or hook up a doodad like this, you'll typically run into lots of usability issues. In particular, how do you get your caret inside that caption box? So the editor has no way of knowing how to do this for you. So the default behavior that you'd see is if you're before the image and you hit the right arrow key, it's just going to jump all the way over your entire image and jump down to the text after it. But what we want to do in this case is when we're before the image, if we hit the right arrow, like I'll do now, we want this behavior where the caret is placed inside the caption element. And similarly, if you're at the end of the caption element and you hit the right arrow, we want to have the behavior where it'll put the cursor on the right hand of the entire image. And this is all quite simple to specify. There's a caption event handler here. That's not the one I want. This is the one I want. This caption event handler here. So you might recall that in the layering of the event flow in the editor, there's a normalization layer. Part of that is to express events in a language that is more suitable for an editing experience, and so it translates it into events like handle left after node. So this event, this callback gets called on your doodad when the caret is after the node and there's been a selection event of moving it to the left. And so all we're doing here, in this case, is saying if the caret is on the right of the entire image thumbnail and the user hits the left arrow, I want to move the caret and put it at the end of the caption. And that's just this code here, that's all it's doing. And similarly, if they hit right when they're right before the image thumbnail, I want to move the caret and move the selection inside the caption. And then we get the behavior that you can see here, where you hit right, we're in the caption, and at the end of the caption, things just keep flowing. And you can add, in Google Wave, we add extra custom behavior, like for when you hit tab. When you hit tab inside the caption, it will move to adjacent captions in other image thumbnails. So these kinds of things are all very easy to hook up with the Doodad API. So that's all I wanted to show you in code. There's only one other thing that I wanted to talk about in this talk, and that's, so this is all, everything you've seen so far has been structural, which is given XML elements, how to paint them, how to handle events around XML elements. What I haven't talked about at all is how to register doodads that control renderings of annotations. So the like I mentioned before, the Annotation Painter breaks up the annotations into spreads and boundaries, and those two abstractions of spreads and boundaries, these are the abstractions that you use to specify renderings of annotations. So there's two kinds of functions you can register to paint annotations. One is a regular paint function, and that says for any region that is covered by a particular annotation, apply these attributes across the elements in that region. So, for example, a bold annotation that covers some text in a region, that annotation gets rendered by a paint function that puts on a style attribute with font weight bold. The second type of function is a boundary function, and these functions get invoked at the boundaries where annotation values change. So the best example of this would be the spell correction annotation, where the little drop-down arrow that you see on the right of the text, that gets rendered through a boundary function. And a boundary function just specifies that given a location where on the left the annotation has one value and on the right the annotation has a different value, we can insert nodes at that boundary. So in the spell correction paint function, or the spell correction boundary function, it says where the value changes from there is a spell correction here to there is no spell correction here, it inserts a node at that location. And these are local nodes that get inserted. So that should explain how you can specify paintings for annotations using the Doodad API. And we now have 5 minutes for any questions. No questions. Yeah, okay.
So if I want to come up
It would be best to do that. There's always a default rendering that kicks in, which you saw at the start, where any doodads where the editor doesn't have painters or renderers registered for them just get rendered as grey boxes. So it won't break someone else's client, but they won't get a particularly good experience. In the Google Wave client, there's a whole separate system of extensions where clients can install their own doodads, like through toolbars and various things. But it's usually best to propagate the code so everyone has it. Yeah, everyone ready to write their own doodads now? Yep. Okay, Dan, is there anything you wanted to throw in?
No, not much. That's basically it. Just a couple of examples for use of annotations. So the light bulb at the end of links is also a boundary in the way selections, when you see other people's selections, the little blob that shows their name, that's another boundary node as well. Yeah, that's basically it. And the other thing to point out is, while in that example we did an image, so it's a very widget kind of example. Basically everything is written with the same, so every single feature in the editor, like from paragraphs, bullets, image thumbnails, gadgets themselves, links, basically everything is done with the same API. So it's not just for building widgets that respond to events, it's for arbitrary editing functionality. That's all.
Yeah. Oh, one last question. Yeah, it's done using the same API. Yep.
So you basically have a handler, line element,
Yep.
have the UL, etc.
Yep, that's right. Yeah, so that just kind of demonstrates that the API is powerful enough to do a wide range of editing features. Okay, thank you very much.